Time for some extra practice on our Honors Algebra 2, Chapter 7, Day 3 material. So remember, there are multiple different ways to do each of these problems, and it's really kind of personal preference. So this first one, you can either change this to exponent form, or you can change it or keep it to radical form. So notice these are both fourth roots right now, so since they're the same type of root, I can just multiply them together. And I have 8 times 2 is 16. Y squared times y to the third is y to the fifth. And now 16 you should know is 4 times 4, which is 2 times 2 times 2 times 2. So this right here is actually 2 to the fourth. And then you have y to the fifth. And at this point you should be okay with the fact that you're going to have a 2 come out. Since your exponent here is larger than your index, you can divide. 5 divided by 4 is 1 with a remainder of 1. And that means that 1y is going to come out and 1y will stay inside of your root. And there's your answer. Now if you don't like that, you can go ahead and you can use exponents. So this is 8 to the 1/4 power times y to the 2/4 power times 2 to the 1/4 power times y to the 3/4 power. 8 is just 2 cubed. And you should notice that these y's have the same bases, so you can add them together. 2/4 plus 3/4 is 5/4. We'll multiply our exponents here, so this is 2 to the 3/4 times 2 to the 1/4. And again, you'll be able to combine because we have same bases. 3/4 plus 1/4 is just 1. That means this whole thing is just 2 to the 4/4, which is 2. And then you're just going to go ahead and you're going to convert to radical form when you're done. You may notice that you're going to have an extra y come out. 5/4 is 1 remainder 1. So that's where your 1y comes out and your 1y, whoops, that should be a 4, and your 1y stays in. Okay, up to you. Let's try another one. Alright, these guys, if it looks confusing, try changing the form. This should be m to the 4/6 over m to the 3/8. 4/6 we can reduce. And now you just are dealing with normal laws of exponents. Okay, they have the same base, you're dividing, so let's subtract. 2/3 minus 3/8. You can use your calculator if you want to type that in. Or you can do a common denominator. This should be 7/24. Just remember to put your answer in root form when you are done. Notice that 7 and 24 do not have any common terms, and 7 is smaller than 24, so there's nothing more to reduce. All right. Keep on going. Same idea with number 3 here, except for your exponents, or excuse me, your variables are already in exponent form, not radical form. So let's see, remember this is just an x to the first. We can subtract our exponents. 1 minus a half is just a half. And then 1/4 and 2/3, your 2/3 is going to be bigger. So when you subtract 2/3 minus 1/4, do a common denominator or use your calculator, you should get 5/12. That 5/12 is going to be on the bottom. Now, remember, this is the same thing as having a 12th root in the denominator. You can't have a root in the denominator, so we will have to rationalize. How do you rationalize when you have 5/12? Remember, you want to make a whole, So the part you need is 7/12. Because 5/12 plus 7/12 is just 12/12, which is just 1. Now remember, you need to have root form. However, you need to have these x and y's under the same root. Right now you have a 2, which would be a square root, and a 12, which would be a 12th root. So we want to get a common denominator so that we can have a common square root. Excuse me, a common radical. So 1/2 is the same as 6/12. And now we are able to put both of these under a 12th root, all over y. There's no radical in the denominator, so you are done. Now, if you had an exponent in here larger than 12, then you would need to divide your exponent by your index and bring a variable out and leave your remainder inside. Okay. Just as a quick comment, some people see right away that this y to the 2/3 is larger and decide they don't want to subtract because they'll just have something in the bottom they don't want to deal with. So instead, let's go from the x to the 1/2 on top. Okay, so what some people are going to do after they subtract their exponents for their x is say, you know what, I'm just going to rationalize this y to the 2/3 right now. Now, if this one is larger on top, just subtract them. It's going to be a lot easier. But in this case, if you want to times by y to the 1/3, what that'll do is that'll bring you straight to this step here. Because 1/4 plus 1/3 is 7/12. Okay, you can type that into your calculator if you don't believe me. And 2/3 plus 1/3 is 3/3, which is just a y on the bottom. Okay, it's up to you. We've got one more. All right, these are some numbers that you can't rewrite like 2 squared or 2 cubed or anything like that. So we'll just break it down into a product of primes. 15 can be broken up into 5 and 3. 6 can be broken into 3 and 2. 10 can be broken up into 5 and 2. And now there's going to be a lot of stuff we can simplify here. For starters, these have the same base and they're being multiplied. So that means we can add the exponents. Just going to rewrite the 2. 3/4 plus 1/2, remember this is a 2/4, it's the same thing, is 5/4. Now, this 5 and this 2, these are not on the same level, so we will have to subtract our exponents. Oops, we won't need division anymore. 3/4 minus 1/3. Let's do our common denominator there. And we should get 5/12, I want to say. Okay. Use your calculator if you want to check that. Our 2's, you have 1/2 minus 1/3. Okay, again, we're going to subtract our exponents. 1/2 minus 1/3 should be 1/6. Let's see, times 3 times 2, 3/6 minus 2/6, yes, 1/6. And then we already had our 3 to the 5/4. Okay, now remember, excuse me, We need these all to be under the same exact root. And right now we would have a 12th root, a 6th root, and a 4th root. So you need to find your common denominator. And let's just say that you think it's 24. Okay, let's just pretend. It really should be 12. But let's just say you think it's 24. All right, just go with it. So we'll come over here. This is a little detour. If your common denominator is 24, this would be 10 24ths, 4 24ths, and 30 24ths, which means they can all go under a 24th root, 5 to the 10th, 2 to the 4th, 3 to the 30th. Now, you got to remember, this exponent is larger than this index. So 30 divided by 24, that's going to be 1 with a remainder of 6. That means 1 3 can come out. So rewrite all this other stuff. And 6 3s remain inside. This is going to be an enormous number, so you would just leave it like this. But your exponents have a common factor with this root, so that means you are not done yet. 10 over 24, 4 over 24, 6 over 24, all of that can be reduced. Because you're dealing with 10 24ths, 4 24ths, and 6 24ths. When you divide those, you get 5 12ths, 2 12ths, 3 12ths. So 12th root is what you really need. And it's now 5 to the 5th, 2 squared, and 3 to the 3rd. Oh, look at that. 5 to the 5th, 2 to the 2nd, 3 to the 3rd. That normally won't happen. This is your answer. So my point is, even if you don't do the lowest common denominator, the LCD, at first, you should still be able to get to the correct answer at the end. Now, if you notice, hey, your LCD is just 12 from the beginning, then you save yourself a lot of grief. This one's already done. This would be, let's see, 1/6. This would be 2 12ths. And 5 4ths would be 15 12ths. And then again, if the 15 is larger than the 12, 1 remainder 3. So 1 3 comes out. And 3 3s stay in, which notice is the exact same thing as this one going the long way. All right, but there are a lot of things to check, so be careful either way you do that.